Recording in progress.
Hello.
Hello.
Am I audible?
Yes, yes.
Okay, so give me just 2 minutes. Let me connect it again. Now I am audible. Okay. So should we start now? Hello. Hello. Okay, so good afternoon, everyone. I am Keshav. I am a PMRF fellow, and I will be taking this discussion hour or problem solving session today for 2 hours. In this, we will discuss first we will brush up about the topics that has been covered last week. Then we will solve some problems. Okay. So should I start now? So in week 1, you have seen what are the numerical methods, and the instructor also discussed about what we say finding the roots of nonlinear problems, with one variable. In that, he has discussed about first the bisection method. Second, he has discussed about the Newton-Raphson method. Okay. So if I start like that, so why numerical method had been introduced here? Suppose we want to solve this problem I equal to u of dx. Okay. So usual procedure will be what? We need to find some variable v such that the differentiation of v will lead to the variable u. Then we will evaluate what? We will evaluate this I equal to v at the upper limit minus v at the lower limit. Okay. But the issue here is not everyone can solve this problem. As you know, before going to integration, first we were introduced about the limits, continuity, functions, differentiability. Then we have moved towards the integration part. So to solve the integration problem, we need to know the knowledge about this continuity derivatives and all. So not everyone can solve this problem. Suppose I have given this problem to a 6th class student, then he will not able to solve. Okay. So is this possible to solve this equation using elementary arithmetic operations like subtraction, division, multiplication, counting, like that? So here a small method has been introduced where by using simple counting and multiplication skills, you can solve this integration. So here we wish to solve this problem using simple arithmetic operations, okay, without doing complex calculation. So here we assume a blackboard kind of thing. Okay, this is a blackboard. This is a blackboard. Then we have drawn this u function here. Okay. Then what we have did, we taken some chewing gums and we just throw on the blackboard randomly. Okay. Once we throw it blackboard randomly, some chewing gum will fall under the curve, some will fall above the curve. We know as integration is what the area under the curve. So here I have denoted the chewing gum that fall under the curve is represented by green and outside the curve is represented by red. Okay. So by doing simple n inside divided by, sorry, this will be n total. So n inside divided by n total multiplied by the area of the blackboard. By using simple this formula, we can calculate the integration I. Okay. So having only the counting skills, some multiplication, division skills, anyone can find the integral. So this is the beauty of numerical method, that numerical methods can use the simple arithmetic operations to solve a complex problem. You know, many of the practical problems that we face in the real life cannot be solved using pen, paper, or analytical methods. There we need these numerical methods to solve the problem, okay, to find the approximate solutions. So here just the definition of numerical method. Numerical method used to reduce all mathematics into simple arithmetic problem and break the arithmetic problem into a series of repetitive calculation. Okay. Can anyone please respond so that I can know whether I am audible clearly or not? Hello? Anyone just please unmute and response. Okay, thank you. Thank you. So what are the advantages of numerical method? First and foremost advantage, I can say that most of the practical problems cannot be solved analytically, but this can be solved by numerical methods. Okay. And many a time the calculation are so complex that by doing pen, paper, or simple analytical solution is not a easy method. It's not easy method. It's not a feasible method to solve. Okay. Maybe it will require good amount of knowledge that most of people do not have. Okay. And what is the disadvantage of numerical method? The first disadvantage, we can say that it will give always a number. It will not, numerical method will not give an expression. Suppose you want to find out, suppose you have thrown a projectile and you want to find out the time of flight relation formula, 2u sine theta upon g, suppose. So numerical method will not give you this formula 2u sine theta, but it will give you the number. Suppose you have defined the velocity, you have defined the angle of projectile, then it will give you the value, some value. Okay. And second disadvantage of numerical method is that it is not exact. It will always give some approximate answer. By approximate means, suppose you have answer 10, but it will give answer close to 10, but not exactly 10. So as an engineer, we want to find the solution as close as possible by using numerical method. So by solving a problem, we always check what is the error. What is the error involved in the numerical method? Okay. And also these are computationally, sometimes these are computationally extensive. So we require hardware and software resources to solve these problems. Okay. So most of the time the problems is solved in a workstation or supercomputer to find the answer to a numerical method. Okay. Now there is a simple method to find a solution of any problem, any physical problem. Suppose you have any physical problem. So how you can find the solution of this physical problem? First, we convert this physical problem into a form of mathematical equation. By using what? By using the conservation laws and constituency relation. This conversion of any physical problem to a mathematical equation is known as mathematical modeling. Okay. And the equation that comes, that is called as mathematical model. Okay. And these mathematical model are many a time generalized one. Suppose you have find the mathematical problem for one problem, then you can apply the same mathematical problem to different problems. Suppose there is a pipe. In the pipe some fluid is flowing. Okay. You have made a mathematical model for this problem. The same model can be applied, or I would say should be applied, to a different problem where we do not have a pipe, rather than we have rectangular channel. Okay. And pipe with some different diameter like that. But it should be a generalized one. And once you got the mathematical model, this model needs to be solved. And most of the time, these mathematical models are solved by use of numerical methods. And the solving of mathematical problem and getting the result is called as simulation. Okay. So this is what we do in the computer. We do simulation in the computer. Before doing the simulation, we need to form a mathematical model. This we form usually by using some pen paper based or some simple calculation. First we define mathematical model, then we solve in a computer. Okay. Now some numerical method to find the roots of nonlinear equation. First we will start by nonlinear equation with one unknown. Okay. The first method is bisection method. So bisection method, if we have some function f of x equal to 0 with some initial guesses, two initial guesses, x1 and x2, such that f of x1 multiplied by f of x2, f of x1 multiplied by f of x2 is less than 0, means opposite signs. If f of x1 is negative, then f of x2 must be positive. And if f of x1 is positive, then f of x2 will be negative. Okay. Then we can find the root in the first iteration as x1 plus x2 divided by 2. So if this is a function, f of x, and there is some initial guesses x1 and x2, we simply take the average of these 2 points. So somewhere here it will come. So this will be my first guess. X in the first iteration that we find, that is represented by x superscript 1. Okay. So I am assuming now, let f of x1 is less than 0 and f of x2 is greater than 0. Then we check at first iteration the root that we have find, x at first iteration, f of x at first iteration. If it is greater than 0, then what will be our second iteration value? Our new interval will be x1, since x1 is negative. So the positive root will be replaced with the new root. Okay. So our new interval will be x of 1, x1 to x of 1. Okay. So the second root will be what? X at the second iteration will be x1 plus x at first iteration divided by 2. And if at first iteration the value of the function was negative, then our interval would have been x at the first iteration, comma x2. Okay. Then our root at the second iteration would have been x at first iteration plus x2 divided by 2. So as you can see, so this is my x1. Okay. So second iteration, what will be the x1 plus x2, x1 plus x at the first iteration divided by 2. So it will come somewhere here. Okay. It will come somewhere here. Now here the function's value is what? Negative. So this will be my x of 2, x at second iteration. So since this is negative value, since here the function has negative value, so x1 will be replaced. So now new interval will be what? X at second iteration, x at first iteration. This will be my new interval. Now I will take average of this. So my x at third iteration will come. Okay, like that. So as we move forward, our interval shrinks and we move closer to the solution. So we need to put some stopping criteria. Stopping criteria means at x at some kth iteration, the function value should be some small real number. This epsilon we define by ourselves. We give in the program some limit, suppose 10 to the power minus 3, 10 to the power minus 4, kind of that. So when the function value is less than that, our program will stop. Okay. So the main advantage or the beauty of the bisection method is the bisection method gives guarantee to convergence. Guarantee to convergence means as we move forward in the iterations, we move closer to the actual solution. Okay. It is not like that first we come closer to the solution, then we move forward. This can be proved like that. Suppose we have some initial guess x1 and x2 at 0th iteration. So after first iteration, what we will get? Either we will get x at x1 will be x1 at first iteration will be x1 at 0th iteration plus x2 at first iteration will be x1 at 0 plus x2 at 0th iteration divided by 2. Or what we will get? X1 at the first iteration will be x1 at 0th iteration plus x2 at 0th iteration divided by 2, comma x2 at first iteration will be equal to x2 at 0th iteration. If we see both the case, if we take the difference, this difference will come x1. One second. It will be minus, I think. It will be minus. So this is minus. So this is minus. So if we take the difference at first iteration means the window interval x1 at first iteration minus x2 as first iteration, that will be equal to x1 at 0th iteration minus x2 at 0th iteration divided by 2. Means our interval will shrink to half. Okay. Similarly, for the second iteration, what the value will be? X1 at second iteration minus x2 at second iteration, that will be equal to x1 at first iteration minus x2 at first iteration divided by 2. This can be replaced by previous formula. So this can be written as x1 at 0th iteration minus x2 at 0th iteration divided by 2 to the power 2. So in general, at kth iteration, I can write x1 at kth iteration minus x2 at kth iteration. That will be equal to x1 at 0th iteration minus x2 at 0th iteration divided by 2 to the power k. If my k is large, means I have moved good ample amount of iterations. So if my k is large or k tends to infinity, this difference will tends to 0. Means what? Means x1 at kth iteration minus x2 at kth iteration. This difference will tends to 0. Means x1 and x2 will converge to a single point. This means bisection methods always converge to a correct solution. Although in some time or most of the time, it requires large number of iterations. Okay. Clear?
So in this bisection method, is there any condition to choose that initial two guesses?
As such, no condition, but you need to make sure that the function value should be opposite signs at these two guesses. Okay. Suppose if the function value f of at x1 is positive, then f at x2 should be positive. Okay, the sign should be opposite. The idea is if function has negative value and some other point function has some positive value, in between, if it is continuous, there will be 1 0. Okay.
Okay.
You can choose
So
any guesses as long as
yeah.
function give opposite signs.
So in case of consider a polynomial like means equation. So in that case, if I whatever guess initial guess or range I considered in in between that range, there may be means two or more than one root may. So
If
my
there is
initial guess,
more than
yeah.
there is more than one roots, bisection method will give only one root. Okay.
Any one of that.
Any one of them.
Okay.
Okay.
Yes, thank you.
Okay. So although bisection method guarantees to convergence, but usually it takes large amount of iterations to converge. So new method has been introduced that is known as Newton-Raphson method. So Newton-Raphson methods, in Newton-Raphson method, we do not require two guesses. We only require one initial guess. Okay. So suppose we want to solve some non-linear equation f of x equal to 0. So what Newton-Raphson do? It repetitively linearize this f of x. Okay. What do we mean by linearization? That we will see now. And this Newton-Raphson method is very sensitive to the initial guess. If you do not clever enough to take a good initial guess, you may not get a approximate or close to exact solution by using Newton-Raphson method. Okay, so it is very sensitive to initial guess. So many a time what people do, first they start with some bisection method, they do some iterations, then between them x1 and x2, suppose after third, fourth, fifth or some kth iteration, they find x1 and x2 at kth iteration. One of them they choose as an initial guess for Newton-Raphson method. Then they solve by Newton-Raphson method. Since Newton-Raphson method converges very quickly, it do not require a large number of iterations, but it is very sensitive to initial guess. Okay. So what is Newton-Raphson method? Now we will see. So suppose we have some initial guess x equal to x at 0th iteration. Okay. So what we do, at that initial gates, we draw a tangent. Okay. This tangent will cut the x-axis at some point x equal to suppose x1. So this where this tangent cuts, that will be our first iteration root value. Okay. So suppose we have a function here. This is our function. Okay. This is our function y equal to fx. Okay. I have taken sub initial guess x1. So what we will do now? We will draw the tangent at this point. Okay. So this is the tangent. This tangent cuts somewhere here. Okay. Where the tangent cuts, that will be my root value at first iteration. So I find the root value at the first iteration. Now from this point, I will draw the tangent again. Okay. It will cut the x-axis at some point. That will be my x at second iteration. So if you see here in this triangle, if I assume this as angle theta, so what will be the value tan theta? Tan theta will be height divided by base. Height will be what? F at 0th iteration x value minus what will be the base? Base will be the difference between x at 0th iteration minus x at the first iteration. So x of 0 minus x of x at first iteration. And this tan theta is nothing but the tangent. So tangent can be written as a derivative at that point. So this will be equal to nothing but f prime at x at first iteration. So if I do some manipulation, I can get the x at first iteration, that will be equal to x at 0th iteration minus function value at the 0th iteration divided by the function derivative at 0th iteration. Okay, so this is kind of repetitive term here first, and these all are in 0th iteration. So I can write in general at k plus 1th iteration, x at k plus 1th will be equal to x at k plus f of x at k divided by f prime at x at k. Okay. So again, we need some stopping criteria. So the stopping criteria will be x at some kth iteration should be less than epsilon, and this epsilon will be some small real number. Okay. So here you can see why it is called repetitive linearization method. So at every point, we assume that the function is linear. Here, we assume the function is linear. That's why we have drawn the tangent, and where the tangent has cut, we assume that was the solution. Similarly, here we assume the solution is, the function is linear. That's why we have drawn the tangent, and where the tangent has cut. If the function was linear, the tangent will be the where the tangent cut, it will give the root. That's why it is called as repetitive linearization method. Okay. Now, these Newton-Raphson methods can be formalized by using Taylor series analysis also. So, I can write here. If any nonlinear function is fx, if this is continuous and n time differentiable, I can write the function value f at x plus delta x, that will be equal to what? F at x plus delta x multiplied by f prime at x plus delta x square divided by 2 factorial multiplied by f prime of x plus dot dot dot. By using the Taylor series, I can write the function f at x plus delta x by using the fx and its derivative at x point. Okay, by using the Taylor series expansion. So here you say, let us assume the solution after kth iteration is x superscript k. Okay, and the next iteration will be what? X k plus 1, that will be equal to x kth plus some delta x. Okay, now we say that at the kth iteration, we do not get the function value 0. Okay, but we hope that after one more iteration, we will get the absolute solution. So this x at the k plus 1th iteration, we can expand by using Taylor series expansion. One second. By using Taylor series expansion. So by using Taylor series expansion, I can write f at x at k plus 1th iteration, that we assume that will be equal to 0. That will be equal to x f at kth iteration plus delta x multiplied by f prime at kth iteration plus some second order terms. Okay. This O is known as order. This O is known as order. Okay. So we neglect second order and higher terms. So simply we linearize f at x plus 1th iteration, sorry, k plus 1th iteration with some linear function. That's why this is called linearization. Since we have neglected the higher order terms and f at k plus 1th iteration was some linear equation and some higher order terms were neglected, that's why it is called linearization. So if we neglect the higher order terms, these terms, if we say equal to 0, this can be written as zero equal to f at kth iteration plus delta x I can write as x at k plus 1th iteration minus x at kth iteration multiplied by f of f at kth iteration. Okay. So by solving this, we will get x at k plus 1th iteration, that will be equal to x at kth iteration minus f at kth iteration divided by f prime at kth iteration. Okay. So this Newton-Raphson method can be realized by using Taylor series expansion. Okay. Now we will solve some example problems to understand these two methods. Okay. So now I required some of your help. I will first pose the question. I will write down the question here, and you should solve this question and give the answer in the chat box. Okay. So the first problem is we need to solve this polynomial x square minus 2 equal to 0, because ultimately we want to find the root 2 value by using Newton-Raphson method. Okay. The initial guess is x equal to 1. And by solving this problem, we want to round off our answer to third decimal places. Okay. So please do this problem. Please do this problem and post the answer in the chat box, what you will get after the first iteration. Okay. Am I audible? Hello.
Yes.
Okay. So please do this problem and write down the value in the chat box, what you will get after the first iteration. Sharfu, can you please off your video? Hello. So anyone got the value after the first iteration, what you will get the solution? You need to make sure that you have round off it to third decimal place. Okay. The initial guess is 1. The function is x square minus 2 equal to 0. Okay, Bharti has got 1.5, 1.500. Good, good, good. Okay. Okay, so So now I will solve this problem. Okay. So here, what is the function? 1 second. Function f of x is equal to what? X square minus 2. Okay. The initial guess x at zeros was 1. Okay. Now what will be the f prime? F prime of x will be equal to 2x. Okay. So what will the value of x at first iteration? That will be equal to x at 0th iteration minus f x at 0th iteration divided by f prime at 0th iteration. Okay. So x at one was first iteration, that will be equal to 1 minus 1 square minus 2 divided by 2 multiplied by 1. Okay. So x at first iteration, that will be equal to 1. This 1 minus 1 will be minus plus 1 by 2. So x at first iteration, that will be equal to 1.5. But we need to write it at 3 decimal places. So our x will be equal to x at first iteration will be equal to 1.00. Now what will be the value after second iteration? So value at second iteration, if I want to find. So x at second iteration will be equal to what? X at first iteration minus f of x at first iteration divided by f prime of x at first iteration. This is the formula of Newton-Raphson method. Now x at second iteration, that will be equal to x at first iteration. What was the value? 1.5. Sorry. Minus 1.5 square minus 2 divided by 2 multiplied by 1.5. Okay. So x at second iteration, that will be equal to 1.5 minus 1.5 square, that will be 2.250 minus 2 divided by 3. So x at the second iteration. Anyone found the value of x at second iteration? Sorry. Yeah, sorry. So what will the value at the third iteration? Similarly, at third iteration, x at third iteration will be equal to x at second iteration minus f of x at second iteration divided by f prime of x at second iteration. Okay. So x at third iteration, that will be equal to what? 1.417 minus 1.417 square minus 2 divided by 2 multiplied by 1.417. What will be the value of this will give? This will give x at third iteration Has anyone found the value? X at the third iteration. So I need to use the calculator for that. So what will be the value at third iteration? Good. It will come approximate to 1.414. Oh, so see how quickly the solution has converged. The initial guess was what? 1. Now after the third iteration, we got value close to 1.414. No? So 1.417 minus 1.417 square minus 2 divided by 2 multiplied 1.417. So what will the value after third iteration? 1.414. So if I now I want to find the value x at the fourth iteration, okay? So this will be equal to x at the third iteration minus f of x at the third iteration divided by f prime of x at the third iteration, okay? If you solve this, you will find the value 1.414 only, okay? So the solution has converged. At early step, we have found 1.414. Now also we have found the same value, means the solution has converged. Now if we move forward at fifth iteration also, it will give the same value, okay? Yeah, this is correct. So I want to stop here for some time. I want everyone to introduce themselves. So participant one by one, unmute themselves and introduce. Hello. Hello.
Yes.
Hi, Dipankar.
Yes. I am Dipankar Bora. I am from Guwahati, Assam.
So you are doing BTech?
No. Means I am working professional.
Okay. Good.
Yeah.
Hello. Good. So Geet Priya from Tirchi pursuing PhD. Sir, I am Dr. Rasmi Deepak from Bangalore. Okay. Okay, so some of you have introduced yourself. So Sarfu, can you just off your video? Hello. Thank you. So one problem we have seen. Now we will try to solve the same problem. Now we will try to solve the same problem using bisection method. Okay. So the same problem, x square minus 2. So x square minus 2 equal to 0. This is a polynomial equation that we want to find the root, and we will solve it by using bisection method. Okay, with initial guesses 1 and 2. Okay, we need to make sure that we round off our answer to her decimal place. So here in the question 2, what we have function? The function f of x is again x square minus 2. No? The initial guess x1 at 0th iteration is 1 and x2 at 0th iteration is 2. Okay. So first thing what we need to do before solving the problem by using bisection method, we need to check the values whether it is of opposite sign or not. One is positive, one is negative, or one is negative, one is other is positive. So we will check that. So f x1 at 0th iteration, that will be equal to 1x square minus 2. That will give the value what? Minus 1. So at x1 0th iteration, the function has negative value. x2 at 0th iteration, what will be the value? 2 square minus 2. So 2 square will be 4 minus 2. That will be 4 minus 2, 2. So this is what? Less than 0. And this is what? Greater than 0. Okay. So our new value of the at first iteration, that will be equal to what? That will be what? x1 at 0th iteration plus x2 at 0th iteration divided by 2. So 1 plus 2 divided by 2. That will give 1.5. 1.500. Okay. Now this will be x1 or x2, that we need to check now. So f at 1.500, 1.500 square, that minus 2, that will give what? That will give some positive number, na? 250. Since this is positive number, so our positive guess will be replaced. So our new interval will be what? New interval will be what? New interval will be 1, 1.500. Okay. Okay. Since function has the positive value at x equal to 2, the x equal to 2 will be replaced with the new value. Now we need to find the other x at second iteration. That will give the value 1 plus 1.500 divided by 2. So it will come what? 1.25. Right? 1.250. Now we need to check the function value here. So f at 1.250, that will be equal to what? That will be equal to 1.25 square minus 2. So what will be the square of 1.25? It's 1, right? Sorry, I don't understand, Geet Priya. Okay, okay. So 1.25 square minus 2. So that will give some negative value. That will give some negative value. 0 point minus 0 point minus 0.4375. So we have got some negative value. This means the function where its value was negative, that will be replaced. The positive one will be the same. So our new interval will be what? New interval will be 1.250, comma 1.500. Okay. Okay. Now x at third iteration, what will be the value? 1.250 plus 1.500 divided by 2. That will give 1.375, I guess. 1.500 divided by 2. Yeah. So this is the value. So if you find f at 1.375, this will also come negative. You can find its square minus 2, no? So that will be minus of 0.93 something. So new interval will be what? Negative one will be replaced. So new interval will be, positive one will be same, 1.375 comma 1.500. Now if you find the x at fourth iteration, that will be equal to 1.375 plus 1.500 divided by 2. So 1.375, sorry, 1.375 plus 1.500 divided by 2. That will give 1.437. Okay. Now I need to find the function value at fourth iteration. That will be equal to square minus 2. So it will come positive 0.066. So positive one. So what will be the new interval? So I can write here. Na? So new interval will be what? So new interval will be what? This new value. This new value will replace the positive one, 1.5. So 1.375, comma, what is the value? 1.437. 1.437. Okay. Now, if you find x at fifth iteration, that will be equal to 1.375 plus 1.437 divided by 2. So 1.375 plus 1.437 divided by 2. So it will give 1.406. Okay. This is square minus 2 if we find. So function value will be x at fifth iteration. That will be equal to what? Minus of 0.023. So minus, so this value will be replaced, the minus one. So new interval will be what? New interval will be 1.406 comma 1.437. Okay. So you can see we are still so far from the actual value. You have seen here in the Newton-Raphson method, in the third iteration only, we have found the solution very close to zero. The actual solution, very close to the actual solution. But here we need to move maybe 3, 4, 5 iterations more to get the actual solution. See, Newton-Raphson method converges very quickly, but bisection method converges slowly. Okay. Should we move forward? Hello.
So is there any limitation in Newton-Raphson method? Means any type of function or only the differentiable function we can use?
Newton-Raphson method, there are limitations in Newton-Raphson method. First thing I have told now, it is very sensitive to the initial guess. So if you haven't taken the good initial guess, your solution may not converge. And it will also depend on the function. Suppose at some point f prime of x equal to 0. Okay. Okay. So what is the formula of Newton-Raphson method? X at kth plus 1, that will be equal to x at kth plus f of x at kth divided by f prime x at kth. Suppose at some kth iteration, we found the function derivative is 0. So if this value is 0, x plus 1, x plus 1 will tends to infinite. Na? अरे यार मैंने थोड़ा I have written the formula wrong. Here it will be minus ना. So it will tends to infinite. Means the solution will be unbound ना. So this is one limitations. मतलब at some place, suppose the function is like that. Some function is like that. It become horizontal or it become parallel to the x-axis at some point. So in that case, the Newton-Raphson method will not give the answer. And you can assume second function also that sir has shown in the class also. Suppose there is some kind of function like that. Okay, this is one function. So your initial guess is somewhere here and somewhere here. Okay. So this is your x1 at 0th iteration. This is what? X2 at 0th iteration. Okay. So if you take the mean, suppose your mean comes somewhere around here. Okay. Somewhere around here. So this will be my x2 at first iteration. Okay. Now these are my interval. This is my interval. Now if we take the mean of these 2 points, it will come somewhere around here. Okay. Maybe I have made the function in the wrong way. Let me check. So this will be my um, what I was trying to convey. Maybe this function would not able to. So yeah, now it will. Now it will. Now it will be. So suppose my initial guess was some x2 at 0th, x1, x1 at 0th. No. So we are talking about Newton-Raphson method. No. So we need to draw the tangent. So you have asked about Newton-Raphson method or this bisection method? Hello.
I asked about Newton-Raphson.
No? So suppose we have function like this. Okay. My initial guess was something like that. This was my initial guess. So what I will do, I will draw tangent to this point. It cuts here. So this will be my x. Sorry, this is 0th iteration. So this is my first iteration value. Okay. Okay. This is my x at the first iteration. If I draw tangent from here, it cuts somewhere here. Okay. It's cut somewhere here. So this is my x at the second iteration. Now, if I draw a tangent from here, so it may so happen that solution may oscillate from this point and this point. Okay, in this kind of function, solution may oscillate from this point to this point, this point to this point. This may happen with some special case of function. So for some function, Newton-Raphson method may not be applicable. I think I have conveyed it, maybe not in very neat fashion, but hello, Deepankar?
Yes, yes, understood. Thank you.
Maybe sometimes solution oscillate between 2 points. Na? So you need to also make sure while solving this problem, Newton-Raphson method, suppose at some third iteration you have found some value. Okay. In the seventh iteration, you found the same value. Means what? Then also after the fourth iteration, you will get the same value. Like that. It may so happen in the case of Newton-Raphson method.
Yes.
Okay. So this is one more problem that we wish to solve. X square minus 5 equal to 0 by using Newton-Raphson method. Okay. So you guys solve and post the what is the root you got after first iteration, second iteration, and the third iteration. Okay. You solve by your own self. I will also solve. So my fx here is what? Fx equal to x square minus 5. And what was the initial guess? I guess 3. It was 3. Yeah, initial guess what? 1. 1 was my initial guess. So this is question number 3. Okay. And x at 0th iteration was what? Is 1. So first we need to find the f prime. F prime of x will be equal to 2 of 2x. So x at first iteration will be what? X at 0th iteration plus f of x at 0th iteration divided by f prime of x at 0th iteration. Okay. So x at 1 at first iteration, this, oh, I'm sorry. This will be minus minus 1 square minus 5 divided by 2 multiplied by 1. So x at first iteration, 1 minus, this will be minus 4 divided by 2. This minus minus will be plus, this will come 2. So x at the first iteration will be equal to 3. So I can write 3.000. This is my x at the first iteration value. What will be the value of x at the second iteration? That will be equal to x at the first iteration minus function at the first iteration divided by derivative of the function at the first iteration. Okay. Now x2 will be what? This is 3 minus 3 square minus 5 divided by 2 multiplied by 3. So x at the second iteration, that will be equal to 3 minus this value will be 9 minus 5 divided by 6. So x at the second iteration, that will be equal to 3 minus this will be what? 4 divided by 6. So x at the second iteration, 2 by 3. What will be the value of 2 by 3? So this will comes as 2.333. Good, good. So Dipankar has found all the values. So you see, after the third iteration and the fourth iteration, it almost got converged. No? If you see Dipankar's value, yeah, it is converged. No? So x at, for the sake of completion, I will also solve this. X at the fourth iteration, so sorry, third iteration, minus f at the second iteration, f prime of x at the second iteration. Okay. So at third iteration, we have found x equal to 2.238. Okay. So at fourth iteration, what will be the value of x? X at the fourth iteration, that will be equal to x, 1 second, x at third iteration minus f of x at the third iteration divided by f prime of x at third iteration. Okay. So 2 point, what was the value? At 2.238, no? 2.238, 2.238 square minus 5 divided by 2 multiplied 2.238 minus 2.238. So it will come around 2.236. So x at fifth iteration will be what? X at fourth iteration minus f of x at the fourth iteration divided by f prime of x at the fourth iteration. Okay, by using Newton-Raphson method. So 2.236 square minus 5 divided by 2 multiplied by 2.236, that will minus, not minus, so it come minus 2.236. So it will again come to 2.236. So you see, here the solution has converged. At the fourth iteration also we have found 2.236, and at the fifth iteration also we have found 2.236. Hello, clear? Any doubt? And any one of you can give me any suggestion what I can improve here? Since first time also I am teaching online. So I am also a PMRF, PhD student here at IIT Kanpur. So as a PMRF THD, I am taking this problem solving session. Yeah, Dipankar, please.
Yes, so actually the screen, I think you can use slightly bigger screen, because it is difficult to see actually.
Okay, I can do one thing. Wait. Now I think it will be visible. 1 second.
Yeah, landscape mode. I think you can use landscape.
Yeah.
Yeah, this is perfect.
This is perfect.
Yeah.
Okay. Thank you. So one more problem we want to solve now. This is the last problem for today. So we need to solve this x cube minus 9x, x cube minus 9x plus 1 equal to 0 by using the bisection method with initial guesses 1 and 5. We want to make sure that we round off this solution to third decimal place. Okay. So only now 3 participants are here: Deepankar, Geet Priya, and Rashmi. So please try to solve this problem. See, I want to make sure one thing. Since this is the first week, so only elementary things are covered in the lectures. So I cannot do much. Only these two methods has been discussed. And so we can solve only problem on these two methods only. As the course will progress, more and more complicated, more involved things will come. And then maybe this discussion or will be more useful. Okay. So let me add one page. Now what is the function? F of x equal to what? X cube minus 9x plus something was there. I will write it again. What was the initial guess? X1 of 0 was 1. X2 of 0 was 5. By using bisection method, we should solve this problem. Yeah, so 9x plus 1 plus 1. Okay, 9x plus 1. So first what we need to do? First we will find the value of this function at these two initial guesses. So f x1 of 0th iteration, that will be equal to 1 cube minus 9 multiplied by 1 plus 1. Okay. So this will come as minus 7. F of x1 of x2 at 0th iteration, that will give 5 cube will be some large number, na? So it will come positive only. 5 cube will be 1 to 5 minus 45 plus 1. That will give as 81, I guess. So some positive number. So this is negative number less than 0. This is positive number. So we can apply the bisection method to solve this problem. So what will be the value of x at the first iteration? That will be equal to 1 plus 5 divided by 2. That will be equal to 3. So our answer will be 3.00 after the first iteration. Okay. Now, what will be the interval? To find the interval, first we need to find the function value at this first iteration. So x at first iteration, f of x at first iteration, that will equal to 3 cube minus 9 multiplied by 3 plus 1. So this and this will get cancelled. This will come as 1, which is greater than 0. So greater than 0, so 5 will be replaced. So new interval will be what? So new interval will be what? New interval will be 1 comma 3.000. Okay. Now, what will be the x at second iteration? 1 plus 3 by 2. This will give us 2. So 2.000. Now the function value at this this will be equal to 2 cube minus 9 multiplied by 2 plus 1. So 9, this will give us minus 9. 8 plus 1, 9, minus 9. So this is what? This is less than 0. So less than 0 means 1 will be replaced. So new interval will be what? 2.000, comma 3.000. Okay. Now what will be the x at third iteration? 2 plus 3 divided by 2. This will give me 2.500. Now we need to find the function value at this. So x at third iteration, 2.5 cube minus 9 multiplied by 2.5 plus 1. 2.5 cube will be what? Let me do the calculation. 2.5 cube minus 9 multiplied by 2.5 plus 1. So this will come as minus 5.875. Okay. This is what? Negative. So 2 will be replaced. So new interval will be what? New interval will be 2.500, comma 3. Now at the fourth iteration, what will be the value? X at the fourth iteration. This will be equal to 2 point. This will give the value 2.750. And what will be the function value at this fourth iteration? 2.75 cube minus 9 multiplied by 2.75 plus 1. This will be equal to minus 2.953. So what will be the new interval now? This value was what? This value was negative, so minus 2.5 will be replaced. So new interval will be 2.750, comma 3.000. Okay. So what will be the x at the fifth iteration? This will be equal to 2.750 plus 3.000 divided by 2. From here you will get x at the fifth iteration. That will be equal to 2 point, what will the value? 2.750 plus 3 divided by 2, 2.875. And f at this will be equal to 75 plus 1. Okay. So this will be equal to minus 1.11. So new interval so see, it will go on for more steps also. Since this value is not very close to 0, na? This value is plus minus 1 something. Okay. So these 4 problems we wish to solve. First problem was what? First problem was x square minus 1. We want to solve by Newton-Raphson method. That we have covered. Then same problem we have solved by using bisection method. X, the initial guess was 1 and 2. In all 4 problems, we have solved this up to 3 decimal places. Okay. Then the third problem was x square minus 5 equal to 0. Initial guess was 1. We have solved this by using Newton-Raphson method. Then the last problem, this is the last problem, I guess. Yeah. So this is solved by bisection method. See. Any doubt? So it was converged after 2 steps. मतलब this was 5th, 6th, 7th, 8th. So clear? Hello?
Yes, yes.
Since only 3 participants are there, you all can unmute and talk something if you have, if any doubt you have, anything you haven't understood in the lecture, and what you want from me to do in this problem solving session from the next week. Hello? Maybe Deepank, you should continue first.
Yes, actually, I just yesterday I have started. Actually, I was late.
Okay.
So in the programming wise, will it be given that programming training also in Python in this course?
Yeah. In this course, it will be given. Matlab, the second week, week 2 will be basics of programming
Okay.
using Python. Okay. So
Okay.
what I can do the next class or next discussion hour, I can do one thing. First 1 hours, I can solve some problem by pen paper based. Then after
Mm-hmm.
that, next 1 hour, we can solve 1 or 2 numerical method problem by using Python. Okay.
Yes.
We make the program here. Or what I make the program, I come here and I explain how I have made it. Okay.
Okay.
Okay. Yeah, Geet Priya, please unmute yourself. So, so one participant left. Now only 2 remains. Hello. Maybe he has some issue with his microphone. So this I have solved in. Okay. So I will upload this lecture will be uploaded. You will get the link. And this whatever I have written here, this also I will upload. Na? I
Sure.
will mail to NPTEL, they will upload. Okay. So what we have done first. So first we have seen why numerical methods are important. And what are the numerical methods? What is its advantages, disadvantages? Then how a physical problems are solved? As it is converted into the mathematical models. It is solved in a computer by using numerical method or analytically. That is called as simulation. And the first step is called as mathematical model. And after this, we get the desired. Then we have seen numerical methods for finding the roots of nonlinear problems. First, we have covered nonlinear equation with only one unknown. There we have discussed first the bisection method. Bisection method solve the nonlinear problem iteratively. The initial guesses, only one condition here, the initial guesses x1 and x2, they should give function value positive and negative, opposite sign. Their multiplication should be, their functions multiplication should be less than 0. Then the next guess was mean of these 2 points, x1 plus x2 divided by 2. Like that we proceeded. The beauty of bisection method was that it guarantees to convergence, but the disadvantage that it is very slow. It is very slow to convergence. It take large number of iterations to converge. Okay. Then we have seen what it's called Newton-Raphson method. So in Newton-Raphson methods, we make an initial guess. This initial guess is very important, since if the initial guess is not right, you may not get the actual solution. You may not get the solution. The solution may diverge. So the initial guess is important. So many a time what people do, they first start with bisection methods. After 2-3 iterations, they found a value, and one of x1 or x2 they take as a initial guess for Newton-Raphson method. Okay. So Newton-Raphson method, we solve the problem by repetitively linearizing it. By linearizing means, suppose I have made a guess some x at the 0th iteration. So what I assume that the function is linear at that point. So what the linear means, we will draw the tangent. Wherever the tangent cut the x-axis, that will be the root at the next iteration. Okay. Similarly, in repetitive fashion, we move and find the next iteration, and we put some condition f at some kth iteration should be less than epsilon. This epsilon is some small real number. This is defined by a user. Suppose I want the accuracy of I want acceptable error of 10 to the power minus 4 order. I will put epsilon as 10 to the power minus 4. Once the function value reaches 10 to the power minus 4, the mod of function value reaches 10 to the power minus 4, my program will stop. Okay. This can be realized by using Taylor series expansion also. We have seen, since the second order and higher order terms, second order and other higher order terms are neglected, and only the linear fx f of x at kth iteration multiplied with delta x f of prime as kth iteration. This is a kind of linear function. So only a linear terms have been considered. That's why it is called linearization. Okay. So new student has joined here, Kritika. Can you unmute yourself and introduce? Hello. Hello, Dipankar, you please mute yourself. Dipankar.
Hello, sir.
Yeah, Kritika. Please introduce yourself.
Good evening, sir. Sir, my name is Kritika Kashyap. I am a student of 12th class.
Oh, 12th class. So 12th class
Yes, sir.
student can also register to NPTEL course. Hello.
Yes, sir.
Can you also, you are also allowed to register in NPTEL course? I'm just asking.
Sir, actually, न्यूमेरिकल मेथड्स जो है उनमें प्रॉब्लम्स वगैरह आती है सर, इसीलिए।
अच्छा, मतलब आपके 12th में भी न्यूमेरिकल मेथड्स है, ये कहना चाह रहे हैं आप?
यस सर। सर
Okay.
एक्चुअली हम नीट एक्सपेरिमेंट्स भी हैं।
अच्छा अच्छा, ठीक ठीक है, गुड। तो आपने शुरू से ज्वाइन किया था लेक्चर या फिर अभी ज्वाइन किया जस्ट?
सर एक्चुअली जस्ट अभी ज्वाइन किया।
हाँ, तो यू आर लेट ना। तो फ्रॉम you first go through the lectures whatever provided by the instructor. Okay, then every Sunday from 3 to 5 we have this online discussion hour or problem solving session. There in first half, in first 1 hour we will try to solve the problem using pen paper, some assignment problems, not assignment problem, this that will be similar to the assignment problem that will be given in this NPTEL course. Then in the second half, what we will try to do, we will take some numerical method and we will try to write down the program in Python. Okay.
Yes.
So what here we have covered, maybe you have seen that first we have discussed about the bisection method, then Newton-Raphson methods.
Yes, sir.
In bisection method and numerical method, this Newton-Raphson, we have solved some problem. Suppose this was the first problem, x square minus 2 equal to 0, that is needed to be solved by Newton-Raphson method. The initial guess was x equal to 1, and we want to find out the results up to third decimal places. So what Newton-Raphson method says, if some function f of x has equal to 0 that we wish to solve has some initial guess x at 0th iteration, then x at the first iteration will be equal to x at the 0th iteration minus f of x at the 0th iteration divided by f prime at 0th iteration. Okay. This can be written in general x at the k plus 1th iteration, that will be equal to x at the kth iteration minus f of x at the kth iteration divided by f prime of x at the kth iteration. So here, since the function was x square minus 2 and initial guess was 1, so what will be the f prime? X prime will be equal to 2x. So what will the value of x at the first iteration? This will be equal to 1 minus, we put the value 1 here in the function, 1 square minus 2 divided by 2, that will give 1.5. But we will not write the answer as 1.5 since we need to write it to up to 3 decimal places. So our answer will be what? 1.500. Okay. Then in the second iteration, x at the second iteration will be equal to x at the first iteration minus f of x at the first iteration divided by the derivative of f at the first iteration. So 1.5 minus 1.5 square minus 2 divided by 2 multiplied by 1.5. This will give as 1.417. This is the x at the second iteration value. Okay. Usually in question, they will write up to how much iteration you should solve the problem. Okay. So here we want to solve up to fifth iteration. So in third iteration, similar formula, x at second iteration minus f of x at the second iteration divided by derivative of f at the second iteration. Okay. So if we put the values here, you will find that x will come at the second iteration 1.414. Similarly, fourth iteration, if you solve, the value is converged now. Third iteration also we have found 1.414. At fourth iteration also we have found 1.414. Means the solution has converged. If you go further iteration, the value will not change. Okay. Now the same problem if we solve by using the bisection method. Okay. So this function x square minus 2 is now solved using the bisection method. The initial guess was here 1 and 2. Okay. Same, the problem need to be solved up to third decimal places, and we need to solve till fifth iteration. Okay. So in bisection method, first thing we need to do, if we have some function and some initial guesses, we should find the value of the function at these points. They should come in opposite signs. If one is positive, other should be negative. If one is negative, other should be positive. So f at 1 will be equal to -1, f at 2 will be equal to 2. So one is negative, one is positive. So this problem can be solved using bisection method. Now in first iteration, what will be the value of x? x1 plus x2 at the 0th iteration divided by 2, that this will give 1.5, means our result will be after first iteration 1.500. Now what will be the value of function at this point? The value will comes as positive. Positive means in the earlier iteration, suppose x1 and x2 was there, at whichever point the function was positive, that will be replaced. So we know at x equal to 2, the value was positive, so x equal to 2 will be replaced. So our new interval will be 1, 1.55. Okay. Now in iteration 2, what will the value? Simply add them and divide by 2. So this will give 1.250. Okay. So now at this point, we need to find out the function value that comes as negative. So negative, the value is negative means in earlier step, that guess will be replaced whose value was negative, whose function value was negative. So at f at 1 was negative, f at 1.5 was positive. So f at 1 was negative, so this will be replaced. So our new interval will be 1.25 and 1.250 and 1.500. Similarly, we will proceed and find the value till fifth iteration. So at fifth iteration, we got this value 1.406. Okay. So like that, our interval will converge as we move forward. So the beauty of this method is bisection method that it guarantees to converges, although it converges very slowly compared to other methods. So usually what people do, they first initially they start with the bisection method, and after some iteration they choose x1 and x2, either of them, as an initial guess for Newton-Raphson method. Since Newton-Raphson method converges very quickly, but the issue is sometimes if the initial guess is not good, it may not converge. Okay. Clear? Hello. So should we end the meeting now? See here, since it was the first week and the instructor haven't talked about much about the programming, that's why we haven't discussed it. From next class onwards, first 1 hour will be dedicated to solving the numerical method problem by using pen and paper. Then we will, next 1 hour, we will solve the problem by using Python or MATLAB programs. Okay. Now we will see how we can use numerical methods known as bisection method to solve a non-linear equation and find its roots. So let us define the function, any function, since we have solved in the class x square minus 2, the same function we will going to use. So suppose f is equal to some function can be defined as like this, x square minus 2. Now we need to define the tolerance. So suppose so here I am taking the tolerance as 1 p minus 2. Okay, this is the tolerance. Now we need to make the initial guesses. Okay, so we have made the initial guess. Suppose a equal to 1, b equal to 3. First thing we need to check whether the bisection method is applicable or not. So if f of a multiplied by f of b is greater than 0, if this value is greater than 0, our code should exit f print f to print the prompt. So the initial guesses are not correct as per bisection method. Okay. Now what we'll do, if this is not the case, else I will just first we will show a prompt message. Calculating the roots, or I rather say root, using bisection method. So suppose we define some x1 equal to a and x2 equal to b. Okay, since it may happen that the code run large number of iteration, still it do not converge. So we need to put some criteria. Suppose I do not want my code to run more than 2000 times, 2000 iterations. So count, initial count I have defined as 1. Some arbitrary C I defined as suppose 1000. If this I will explain what is C. While absolute of f of C is the value at some iteration. Absolute of f is greater than tolerance what will be? The C will be x1 plus x2, x1 plus x2 divided by 2. Now we need to find the interval. So if function of x1 multiplied by function at C, so suppose the value which is same, the function value if at f at C is same as f at x1 in sign, then we need to replace that. So if negative means this is the opposite sign, so opposite sign means the other variable needed to be replaced. So x2 will be replaced by C. Else what will be? Else x1 will be equal to C. Okay. And now we need to put some criteria on the count. So count equal to count plus 1. Okay. Now I am writing the count criteria. If count is greater than 2000, I need to break. I need to go out of the while loop. Okay. I need to put one more in for the this if else command. Now if I evaluate this, it is written calculating the roots using bisection method. Now it has run. So what is my value now? So it has run for 8 count, means 8 number of times. After 8th iteration it has been converged, and my root will lie between these two values. Okay, so I can replace it as so either x1 or x2 I can choose as my root. Okay. Now one more thing I want to add. Suppose the initial guess you made is already a root. So in that case what we need to do is if absolute of function at A is less than tolerance, in that case f printf the initial guess equal to percentage f, suppose I am writing, is the root. full stop, no need to use bisection method. Okay, similarly, rather than a, if b is the actual root, the same thing I need to write again. Suppose I run the code now, just evaluate the section. It is showing an error. Else if why it is showing an error? It's the last case. So if I calculate it again, see, calculating the bisection method, and it has calculated the value. Now suppose I change it to, now I decrease the tolerance. I want to go for final resolution. So still it has converge after 8th iteration. I also should write f in f the root is equal to percentage f comma c if I calculate. So calculating the bisection method, why it is showing some error. Okay, f print no, printf, f printf. Control A, evaluate. See. So calculating the bisection method, the root is showing the value. Now if I increase the resolution or the tolerance further, see, now it has converged after 12th iteration, sorry, 14th iteration. I increase this further, suppose 10 to the power minus 5 tolerance, control A, evaluate. So now it converges after 16th iteration. Okay, now suppose one of my initial guess is 1.41, 1.41, 4, tolerance is somewhat lesser. Okay, so first I should save this code. Suppose I am saving this code to bisection method. So if now if I run with this code, see the initial guess 1.414 is the root, no need to use bisection method. Okay, I defined this C here, this won't show an error. Suppose I have run, so no need to use. Control X, Control X. Suppose this is 1 and this is 1.414. Then initial guess is not correct, it is showing, since 1 is negative, this may be showing the value negative. 5. So this is the one of the rule, no need to use the bisection method. Okay, like that you can make the code on bisection method. Similarly, for Newton-Raphson method also you can make the code. I hope you have understood. Thank you.